Multiplying polynomials. So we will learn how to multiply polynomials with the polynomials, and we will see here that the distributive property and the product rule of the exponents are the key to the multiplication of polynomials. So remember the product rule of exponents. So whenever we are multiplying two exponential expressions with the same base, we add their exponents. It's n plus m. In the multiplication, instead of writing them 2 times, since their base is same, so we keep the same base and add their exponents. And the distributive property is, if you have x plus 1, there is a x outside the bracket, we are multiplying this, so distributive means we are distributing this x inside the bracket. Whatever is here outside the bracket, right now it is x, so we are distributing this inside the bracket. So there is multiplication sign in the middle, so this x will be multiplied to each and everything inside the bracket. So it will be x times x plus x times 1. And here we will use the product rule of the exponents. We have the two exponential expression with the same base, we will add their exponent. So we get x squared plus, now x times 1 is just x. So this is called the distributive property, and we can also call this a multiplication of two polynomial. So this x is a monomial, and this x plus 1, this is another polynomial, and it is a binomial. So when it is a monomial over times by binomial, or monomial times by any polynomial, we just use the distributive property, and this is called the multiplication of polynomials. So let's do one more example. 2x squared times 5x cubed plus 3x minus 1. So this is a monomial times by a polynomial. So this is a monomial times by a polynomial. So we are going to use the distributive property. So this 2x squared is going to multiply by each and everything that is inside the bracket. So we get numbers will be multiplied with the numbers. So 2 times 5 is 10, and x cubed times x squared plus 3 times 2 is 6, x times x squared minus 1 times 2 is 2 times x squared. Now we will use the product rule of the exponents. We will write these exponential expression by adding their exponents. So this is 10x5 plus 6, x has exponent 1 plus 2. So 6x cubed minus 2x squared as it is. So now we have to first see, are there any like terms so that we can combine? But in this case, we have one term x5, one term x cubed, one term x squared. So all are unlike terms, so we have to stop here. We cannot further simplify. Okay, so now let's do one more example where we will multiply binomials with polynomials. So let's do x plus 1 times x squared minus 3x plus 5. Let's do the multiplication of these two polynomials. So we are going to use a foiling method. So what is that method? So first we will take the first term of the first polynomial and multiply this with the second polynomial. So we will write x times the whole second polynomial. Now we are going to take the second term and multiply that with the second polynomial. So it is plus 1, the second term is plus 1. We are going to multiply this with the second polynomial. So one by one, what we did, one by one we took each and every term of the first polynomial and multiplied with the second polynomial. Now use the distributive property. and similarly use the distributive property here and open all the brackets. So we get x cubed minus 3x squared plus 5x, and here plus 1 is multiplied inside, we get plus x squared minus 3x plus 5. So we use the distributive property. Now combine like terms. These two are like terms. Like terms again, having the variable part is exactly same. These two are like terms. So write this as it is, x cubed. X squared terms, combine them. Minus 3x squared plus x squared is minus 2x squared. 5x minus 3x will be 2x, and then plus 5. So here we will stop because all are unlike terms. We cannot further simplify this, and we will say this is the product of two polynomials. Let's do one more example. So 2x, let's say x plus 1 square. So what that means? So remember, this is not equal to x square plus 1 square. You cannot just distribute 2 inside. It is only true if there is a product, or if there is a product sign and you have a square, you can distribute the square to everything. If you have the division and then square, we can distribute this square to both numerator and denominator. This result is only true for multiplication and division. This is not true for plus or minus sign in the middle. You cannot distribute this inside if there is a plus or minus sign. Okay, so this is a very important to know that. Okay, if this is not equal to that, then what is that equals to? So let's do that. So it is 1x plus 1 square. So square means we are exponent 2 means we are multiplying the base by itself 2 times. Correct? 2 copies of x plus 1 are multiplied together. Now, how we can multiply these two polynomials? We just learned the filing method. Take each and every term of the first polynomial and multiply it with the second polynomial. So we can write this as x times first term times the second polynomial. Now take plus 1 and then multiply again it with the second polynomial. Now use the distributive method. We get x squared plus x, then plus x plus 1. And now combine like terms. So we get x squared plus 2x plus 1. So x plus 1 squared is not just 1 x squared plus 1 squared, that is 1. It is something more than that. So this is equal to this. So this is how we do the multiplication of polynomials. Thank you.